In this video, I want to explain a process or introduce to you a process that often trips students up, and they often forget how to go about writing an expression with sine and cosine in this other form. So it might look like r sine theta plus alpha or r sine theta minus alpha, or it might be r cos theta plus alpha or r cos theta minus alpha. Okay, could be any of those. And really what I want to do is explain as to why this works in this video. In the next video, I'm going to show you how to actually go about it, but in this video I want to explain why it works. Now, what I suggest you do is you go on to either Autograph or online there's Desmos, okay, very useful graphing package, and you type in y equals 4 sine theta or y equals 4 sine x plus 3 cos x, okay, and you take a look at what that looks like, and what you find is the curve you get will look like a sine curve or a cos curve for that matter. But it will look like a sine curve. And what it's going to be, and how this works, is, I haven't really drawn that line at a perfect place. Let me try this again so it's more understandable. Let's draw the x-axis first. That's better, a bit better. So I'm not going to draw in the, I'm not going to draw in the y-axis there, so I might draw in the y-axis here, for example, okay? To accentuate the point that although this might look like a sine or a cosine curve, essentially what it is it could be a sine curve, but it might be going through other points. So it's not 1 and minus 1, for example. It might be something like 15 and minus 15, for example. So what's happened is the sine curve has been stretched parallel to the y-axis. And also, because this isn't quite sine, because it's not going through 0, 0, there's also been a translation that has happened as well. Okay, so maybe the curve has been translated along by alpha, some value, okay? So what I'm trying to hint at is that the curve that you're getting is just a transformation, a couple of transformations that have occurred to a sine curve. So this is what is working here. The r takes care of the stretch in the y direction, okay, parallel to the y-axis. So this is a stretch parallel to the y-axis by factor r. Okay, so our curve is actually going between minus r and r, and the alpha here takes care of the translation along the x-axis. So this is a translation by minus alpha 0. So it's a curve, and a sine curve, that's been stretched parallel to the y-axis and then shifted along by a certain amount, either to the left or to the right. And that is why I am now able to write this expression in this format. I just need to work out what r and alpha, what they are, okay? And the way to go about that, I'm going to show you in the next video, and uses the compound angle formulae, okay, from the formula booklet. But that is essentially why we can make this jump, okay, why we can go through this process.